Hello, welcome to this presentation of International Plumbing Code. My name is Thomas, and in this presentation we're going to look at Chapter 7, which is all about sanitary drainage. Now, code, of course, is often telling us what we are supposed to do. It doesn't always go into why we do what we do, but when it comes to Chapter 7, I think it's really important for us to understand why we do what we do. Let's go back in time. As we consider the importance of sanitary drainage, we have to recognize that sanitation saves lives. Sanitation is referring to the way that we handle the waste that we create. Check out this old political cartoon. Many years ago, diseases such as typhoid fever, cholera, dysentery would sweep through the United States and throughout the world and would kill people. Sometimes a whole third of a population would be annihilated by this. The symptoms of these diseases were horrible. You couldn't eat or drink. It was basically diarrhea to death. This political cartoon illustrates the way that typhoid would sweep through the country. But there was one thing that they could do, and the weapon that they had against it was prevention. Prevention that comes through sanitary living. Now, it's taken a long time for us to come to where we are with plumbing. The early plumbing fixtures were a failure. Often they would leak, they would rot, it would stink up the house. For this reason, the public mind was really against having that sort of filth inside the house. And it took time to be able to develop fixtures that worked well enough that they weren't a filthy mess. And also for people to overcome the mental wall that was up there, just like, no way, you wouldn't want that in your house. John Harrington is one man. He was a member of the Royal House of England and an inventor, and came up with one of the first models for the actual flushing toilet. But he was laughed at and thought to be crazy because of this horrible thing that he'd come up with. It made a lot of noise, but he was pioneering in what we have today. John Crapper is known for bringing the toilet to the public. People muse over his name, but John Crapper really helped bring the toilet and the plumbing necessary into the public, helping people to see that it is a good thing, that it can benefit you in your personal space. Ultimately, having a proper sanitary drainage system protects the health of the nation. This is one of the great and important roles of plumbers. We are here to make sure that life will continue and that the quality of life is preserved. So when we look at what we are supposed to do with drains, vents, etc., let's also keep in mind the reasons why we do it. We do this because when we do it right, it protects health and sanitation. So on we go into the International Plumbing Code Chapter 7, looking at sanitary drainage. I invite you to pull out your book, follow along, make sure you understand what these sections are talking about. Let's start in 701, General. As we look at the scope of this chapter, it says the provisions of this chapter shall govern the materials, design, construction, and installation of sanitary drainage systems. That's what this chapter is all about. Now 701.2 talks about where sewer is required. It says sanitary drainage piping from plumbing fixtures in buildings and sanitary drainage piping systems from the premise shall be connected to the public sewer. Anywhere that there is a public sewer, it should be connected to the public sewer. Now, different laws in different jurisdictions may dictate at what point that is an absolute requirement. For example, in Utah, the Utah Amendment states that if your building is within 300 feet of the public sewer, you are required to connect to that public sewer. Whereas if it's further away, you could have a private drainage system like a septic system. One exception to this rule in 701.2 is the gray water systems, where we try to reclaim or reuse some of the wastewater, but nothing that would contain human fecal matter. Gray water is addressed later in this code in Chapter 13 and 14. 701.3 requires the separate sewer connection for each building. Any building on any parcel or lot would need to be connected individually to the public sewer. This is to avoid problems and conflicts with liability. For example, if two properties have a shared sewer line and it gets clogged, who pays for it? Who clogged it? How do you prove that? It just gets messy in more than one way. So they say every building, every lot has to have an individual connection to the sewer. Here's a drawing to examine. Across the bottom is the public sewer. There are 4 different properties with 4 different buildings. The 2 buildings above, Building A and Building B, don't have a property line or a lot line that's right by the public sewer, but there is a dedicated public sewer easement. So this section coming up through the middle is also public sewer, and then they have an individual connection to that. Now, what if you have more than one building on one property? Well, because both of those are on the same property, you can have one sewer connection to the public and multiple connections within the property, because obviously the owner is going to be responsible for any of the buildings that are on that property. 701.4 talks about sewer treatment. It says sewage or other waste from plumbing systems that is deleterious to surface or subsurface waters shall not be discharged into the ground or into any waterway unless it first has been rendered innocuous through subjection to an approved form of treatment. Hey Siri. Define deleterious. Deleterious, causing harm or damage. Yeah, that's what that means. Harmful, damaging. Anything that would be harmful in our wastewater as we return that water to streams, waterways, and whatever has to be clean enough that it's not going to be hazardous or damaging anything downstream. Similarly, 701.5 talks about damage to the drainage system and public sewer. Obviously, any waste that we put down there should not be damaging the system, so we would have to treat that drainage waste before it goes down. Now, Chapter 10 goes over traps and interceptors. Interceptors and separators are a good example of pulling the oil or pulling other things out of the water before it heads down into the public sewer and causes problems. Grease is another great example of that. It's going to clog everything up, so we pull the grease out first, and then the wastewater can go down the sewer. 701.6 refers us to test and inspections and says, hey, we've already addressed that in section 312, so as far as how to test drainage systems, it's all in there. And 701.7 just mentions engineering systems and that they would have to conform to the provisions of the code. In 702, we look at the materials that are allowed to be used. Think about some of these questions for just a minute as we consider drainage pipe. What qualities do you want out of a drainage pipe? Some pipe is more rigid than others. Some is easier to install than others. What advantage is it to know the qualities of different types of pipes? Now here's a fun one. Let's list out what are some of the pros and cons for each type of pipe, and in what situations would you use each of these types of pipe. Table 702.1 gives us a list of piping materials that can be used above ground. We then see another table, 702.2, that shows what can be used below ground. But let's focus on this one for above ground drainage waste and vent. First of all, we have acrylonitrile butadiene styrene, or ABS. And yes, this is why we call it ABS, because no one wants to go into the supply house and ask for acrylonitrile butadiene styrene pipe and fittings. Cast iron is on the list. We have copper and copper alloy pipe or tubing, although copper is so expensive for a drain that it's rarely used. Galvanized steel is approved for drainage and vent piping, and glass pipe for chemical systems. But more often we see polyolefin, which is a plastic, and it's very resilient against chemicals. So for chemical systems nowadays, we use that plastic type more than glass. Polyvinyl chloride, or PVC, and this is another abbreviation, because again, we're not going to be asking for polyvinyl chloride every time we want PVC. And there's also polyvinylidene fluoride, or PVDF. And finally, we have stainless steel on the list. You and I know the ones that are most commonly used because we see them every day. PVC, ABS, cast iron on that list, right? But there are others approved, and it's good to be aware of those. Let's have a look at table 702.2. As you go down the list, you'll find that most of the things listed on that table are the same as the last one, the above ground. But they do have a few other options, including polyethylene, or PE. But they've also removed glass pipe, and you can imagine how much fun it would be to install glass pipe on an underground with lots of rocks. So for obvious reason, right? Then we have table 702.3, which is the building sewer pipe list. And on that list, we see, different from the other lists, several co-extrude composite forms of ABS and PVC. And what we mean by that is you can get PVC sewer pipe right? That's an example of this. It has a thinner wall. It's used specifically for sewer pipes underground. Not something that you would use inside the building, but definitely an option for sewer pipes. Concrete and vitrified clay are also approved for building sewer pipes. In 702.5, the code tells us that there is a limit to the temperature that can be put down. Obviously, the temperature of the waste can have a big effect on the pipe, so if it's too hot, maybe it's coming from steam or boilers or something, it could do damage to the pipes. So it gives a temperature rating, and it says where wastewater temperature will be greater than 140 degrees Fahrenheit, the sanitary drainage piping material shall be rated for the highest temperature of the wastewater. So if you're dealing with super hot water down the drains, you're going to need to make sure that pipe can handle it, or that there's some way to cool that before it goes down the drain to avoid damages. Another form of waste that can damage the pipes is the chemical waste. So laboratories or anywhere that they're using harsher chemicals are going to be handled with a separate drainage system from the sanitary, and also treated so that we can eliminate those harsh chemicals. Now, a quick review when it comes to chemicals and what are we really concerned about here, it has to do with the pH scale. The pH scale goes from 0 to 14, and 7 in the middle is neutral. Typical water should be somewhere around 7, where it's not causing us any problems. Anything less than 7 becomes acidic. Anything more than 7 is an alkaline or basic. 6.8 is considered corrosive, so even when it just barely dips below 7, that acid starts to be a corrosive thing. Lower than 5.5 is where it would require an acid waste system. Now we're getting into really heavy acids that will eat through anything and everything. Acid wastes in vapor state are also dangerous. Therefore, this is an entirely separated system, and that means drains and vents. There's no connection to the normal sanitary drainage system. As we talk about pH, are you familiar with the pH levels of drain cleaners? You definitely want to watch what you're dealing with. Some drain cleaners are lower on the pH scale and they're acidic. Some are actually higher and are basic. You don't want to use those together because they will react, and that can be very dangerous. Alright, before we go any further, I just want to take a time out and go back to definitions in Chapter 2 and make sure that we're clear on the difference between a building drain and a building sewer. As you can see in the diagram, the building sewer and the building drain are the main pipe that comes out and conveys waste from the building. But the building drain is the pipe that comes horizontally from the building and extends 30 inches past the building. Once it hits that point, it becomes building sewer. So as we talk about building sewer pipe or building drain, it's important to know at what point does that main drainage pipe become building sewer. With that in mind, let's look at 703, where we consider the building sewer. 703.1 talks about how to handle the building sewer pipe near the water service, and refers us back to 603.2. So in 603.2, we learned about the importance of separating the water service pipe from the building sewer if the building sewer pipe is not listed on table 702.3. 703.2 talks about the drainage pipe in filled ground. So this means they've brought earth in to kind of bring the level up, but when that pipe is in there, we have to make sure that filled ground is compacted enough that it's not going to settle and cause bellies or problems with that building sewer. 703.3 addresses sanitary and storm drains. It says where separate systems for sanitary drainage and storm drainage are installed on the same property, the sanitary and storm drainage sewers or drains shall be permitted to be laid side by side in one trench. This may save you quite a bit of time as you're trenching to put the two pipes together and just grade it out, but they should be separate systems. And in many places we have separate sanitary drainage and storm drainage. Now let's say that you're going to connect or reuse an existing building sewer, or maybe say there was a building that was taken down and there is a sewer there for connection, but we're going to put a different building up. In those cases, we need to make sure that that sewer pipe is in good enough shape and big enough that it's going to handle whatever the new requirements are going to be. So in 703.4 it says, the building sewer shall be internally examined to verify the pipe is sloping in the right direction, that it's not broken and is not obstructed by roots or whatever else, and is sized for the drainage load. So basically we're going to verify all of that before we go building a new building and hooking up to that drain. 704 talks about drainage piping installation, and 704.1 zeroes in on the slope of horizontal drainage pipe. You and I know that this is the most important thing for a plumber, is to install pipe so that it runs downhill, right? This is exactly where in code it tells us we have to slope our pipes. It says horizontal drainage piping shall be installed in uniform alignment at uniform slopes. That means even as it goes. What happens if you don't have any slope? Well, obviously everything just sits in the pipe. But did you know that if you have too much slope, that is also a problem? Because the fluids, the liquids, will outrun the solids if there is too much slope over distance. So we need a nice, even, uniform slope in order to keep all the solids flowing along and moving downstream. And this brings us to table 704.1, slope of horizontal drainage pipe. There are a list of pipe sizes on the left column and minimum slopes on the right column. This one you ought to have memorized. Let's look at the sizes, 2.5 or less. Now, for the most part, we don't often use 2.5-inch pipe, but remember, this is an international plumbing code, so there may be other pipes out there that we don't use. In any case, the smaller pipes need at least 1/4 inch per foot grade, also known as 2%. For pipe sizes from 3-inch to 6-inch, you can slope that at 1/8 inch per foot, or 1% grade. Anything 8-inch or larger, and you can run 1/16 inch per foot, or 0.5% slope. As we are installing drainage pipe, it is critical that we never reduce the pipe size in the direction of flow. This is spelled out in 704.2. The reason for that being, as you go along downstream, if you shrink the pipe size, you will very likely have blockages and clogs. So it always gets bigger as it goes. Now there are a couple of exceptions, particularly closet flange. We have the 4x3 toilet flange that can glue into a 4-inch pipe. That is a reducing fitting, and that's okay. We have the 4x3 closet 90, but it has to be installed in the upright position with the 4-inch coming up, reducing down to the 3-inch. Finally, we also have the offset closet flange. This is also a reducing fitting. It will get smaller as it goes in the direction of flow, but these are the rare exceptions. Everything else should stay the same size or get bigger as it goes downstream. 704.3 talks about connections to offsets and bases of stacks, and introduces us to a special requirement to avoid problems with the hydraulic jump. Let me read what it says. Horizontal branches shall connect to the bases of stacks at a point located not less than 10 times the diameter of the drainage stack downstream from the stack. Have a look at this illustration. We have a vertical stack. As a fluid comes down a vertical pipe, it hugs the walls until it comes to the bottom. When that pipe turns horizontal, some of the fluids can flow with the surface of the wall, but some of it's going to come off of that, and there is a collision of fluids. A certain turbulence is created, and we get this hydraulic jump. It's kind of like a wave. As those fluids collide and they hit, they kind of rise up and then it settles down. Now, if we were to connect a horizontal branch at that point, there is the possibility that that hydraulic jump could restrict the flow coming into it, or maybe even stop it. Now you might say, how often is that going to happen? Well, in a residential setting, maybe not all that often. But if you're in a large building, a skyscraper even, the chances of having continual flow down a stack is kind of good. And so for that reason, we have this general rule: anytime there's a stack, you come 10 times the pipe diameter downstream before you connect in any horizontal branches. 704.4 talks about future fixtures. There are times when we may be roughing in some drainage pipe, knowing that eventually something will be added on to a part of this system later, but in the meantime we can just cap that, and that is acceptable by the code. Alright, we're going to stop there for this presentation. We've covered from 701 to 704 in International Plumbing Codes Chapter 7 on sanitary drainage. Join me next time. We'll pick it up in 705. I'll see you then.